In this video, we're going to go through classifying and balancing chemical reactions. So our essential question, how do we identify different types of chemical reactions and balance them to make sure the numbers of atoms is the same on both sides? So we're going to begin by going through 4 types of chemical reactions. The first type that we're going to look at is called a single replacement reaction. So in a single replacement reaction, we have a compound, which is made up of a cation and an anion, and then we have another piece that wants to come in and swap out. So that piece can be either a cation or an anion. And it will basically come in and it is going to replace one of the pieces. So in this case, it's going to kick out the other cation. So B would be our cation, and it's going to pair up with the anion C. Okay, so it'll make a new compound that'll contain A as the cation, C as the anion, and then B is going to get kicked out. Okay, so that is a single replacement reaction. Okay, next we're going to look at a double replacement reaction. In a double replacement reaction, we have 2 compounds. Okay, 2 ionic compounds right here. All right, and pretty much what's going to happen is our compounds are going to trade cations. So the cation from A will pair up with the anion from our second compound, and then B is going to pair up with the cation from compound 2. So we'll end up with 2 new compounds. So we're replacing 2 things, hence the name double replacement. And we end up with 2 new compounds consisting of different cations and anions. Okay, now we're going to look at a synthesis reaction. The word synthesis, if you think about it, means to make something, to synthesize something. So in a synthesis reaction, we're taking 2 pieces, cation and an anion, and we are putting them together into a compound that contains a cation and an anion. That's it. Decomposition is the opposite. So again, look at the word decomposition. Think about when something decomposes, it breaks apart into smaller pieces. So we have this compound AB, and it is going to break apart into cation A and anion B. That's it. So those are the 4 types of chemical reactions. So now we're going to look at classifying some reactions and balancing them at the same time. So these are the steps to balance chemical reactions. We're going to start by writing the unbalanced equation, or looking at the unbalanced equation if it's given in the question. Next, we're going to list the number of atoms of each element. I have a method that I'll demonstrate on our first example. Then we're going to balance the atoms of one element at a time. When we balance, we're only allowed to add coefficients. We cannot change the subscripts, which we'll look at when we get to an example. And we're going to do this for all the elements until it's completely balanced. Okay, so let's look at this reaction. It says balance the following chemical reaction and classify the reaction type. Okay, so in this reaction we have 2 pieces that are combining to form a compound. This is going to be synthesis. All right, on the left-hand side of our reaction are the reactants. On the right-hand side of our reaction are the products. All right, now we're going to divide our reaction in half. I do it right at the arrow, separating the reactants and the products. And I'm going to make a list of all of the different atoms we have. On the left-hand side, we have 2 hydrogens. We have 2 oxygens. On the right-hand side, we have 2 hydrogens. There's no number here, so that is 1 oxygen. So if you look, our hydrogens are balanced, but our oxygens are not. So I have 2 oxygens on the left-hand side. I only have 1 oxygen on the right-hand side. So we're going to need to add a coefficient. So I can't just put a 2 here. That's not good. That's breaking the laws of chemistry. What we are allowed to do is put a coefficient in front of it. So if I put a coefficient in front of it, it is going to multiply each part of that compound. So there's 2 hydrogens. So 2 times 2 now makes this 4 hydrogens. 2 times the 1 oxygen makes 2 oxygens here. Okay, so great, I fixed the oxygens, but now the hydrogens aren't balanced. So to balance the hydrogens, I need 4 hydrogens, so let's put a coefficient of 2 in front right here. 2 times 2 makes this 4. And that's it. You want to just make sure that all of the atoms balance. Now, the reason we're balancing this is because of conservation of mass. So the amount of matter on the reactant side of our chemical reaction should equal the matter on the right side. So the number of atoms on the left side should equal the atoms on the right side. Okay, so all of our ingredients that we're combining should still be accounted for on the product side. Okay, so conservation of mass is the principle that we're using here to balance our chemical reactions. All right, let's look at another one. So in this reaction, we have iron by itself, and then we have a compound here, which is made up of a cation and an anion. Okay. Now, in this case, we have a single replacement reaction because iron is going in and iron is pairing up with chlorine, and then hydrogen gets kicked out. So this is a single replacement reaction. All right, and this one is a doozy. So let's split it in half and let's list out all of our atoms. So we have 1 hydrogen, 1 iron, and 1 chlorine. On the right side, 1 iron, we have 3 chlorines, 2 hydrogens. Okay. Now, when you're balancing, sometimes you have to go back and forth to find the right combination. Okay. So let's start by balancing the chlorines. So we have 3 on the right side. I need 3 on the left. So let's put a 3 right here. 3 times 1 makes this a 3. 3 times 1 makes this a 3. Great. Chlorine's balanced, but hydrogen is not. Okay. So sometimes when you're balancing, this happens. So look at hydrogen. We have 2 and a 3 here. The least common multiple between those is 6. So 6 is the number that we need to get to. So let's change this. Instead of 2, let's change it to 6. 6 times 1 makes this 6. 6 times 1 makes this a 6. Okay, so now we have 6 chlorines on the left, and we need 6 on the right, so let's put a 2 in front of our iron chloride. So that makes our iron 2. 2 times the 3 chlorines makes that a 6. Okay, now the hydrogens are easy to balance. We have 6 on the left, we have 2 on the right, so let's put a 3 in front right here. 3 times 2 makes this a 6. All right, and last but not least, let's go ahead and balance our iron. So let's put a 2 in front of our iron. 2 times 1 makes that a 2. Okay, and we are balanced. All right, let's move on to this next example. So here we have 2 ionic compounds. And if you notice, the barium ends up matching up with the sulfate, and my pen's not working. And then the sodium matches up with the chlorine. Okay, there we go. So this is a double replacement reaction. Because we are replacing the cations in both reactions. So we have a new cation in each equation, or in each compound. Okay, so let's split it in half, and let's make a list of what we have. Okay, So on the left-hand side, we have barium and chlorine, sodium, Na. Okay, now, we do not want to split up polyatomics if they exist on both sides. So in this case, sulfate exists on both sides. So we do not have to split it up. So do not split up polyatomics if they exist on both sides. All right. Oh, well, plural. How about polyatomic ions? That'll make spell check happy. There we go. All right. So what I mean by that is let's write it as SO4 sulfate. Okay. You're only allowed to do that if it exists on both sides. You don't need to split it into sulfur and oxygen. You can, but it makes your life a little bit easier if you don't. All right, so we have one barium, we have two chlorines, we have two sodiums, and we have one sulfate. On the right-hand side, one barium, one chlorine, one sodium, one sulfate. Okay, so sodium and chlorine are the only things that aren't balanced, so this one looks complicated, but if I put a 2 there, guess what? This becomes 2, and this becomes 2. And now we're balanced. All right, we have one more here. So what I'd like you to do is pause the video and try to work this one out on your own. Like actually pause the video and work this one out on your own. Identify what type of reaction you have and balance it. Okay, so I'm assuming you've paused the video, or maybe you're just too lazy and you just let the video play. Either way, it's fine. Let's go through this. Okay, now Cl03 is a polyatomic that's listed on our table, but notice it's not on the right-hand side. So we have to split this up. So we have potassium, we have chlorine, and we have oxygen. Okay, so we have one potassium, one chlorine, 3 oxygens, one potassium, one chlorine, 2 oxygens. So same situation that we had before. We have a 2 and a 3. Least common multiple is a 6. So let's get 6. So to do that, let's put a 2 in front of our compound on the left-hand side. 2 times 1 makes this a 2. 2 times 1 makes this a 2. 2 times 3 makes that a 6. On the right-hand side, I need to get 2 for potassium and chlorine, so let's put a 2 here. So these both become 2. And now to get our 6 oxygens, I'm going to put a 3 right here. Okay. So notice we have a compound that is turning into 2 separate pieces. So this is a decomposition reaction because it is decomposing into 2 smaller pieces. Okay, so that is our decomposition reaction here. So we went through how to balance equations, and we also went through earlier how to identify the 4 types. So remember, we have single replacement, double replacement, synthesis, decomposition. And that's it.